Ladies and gentlemen, I want us to have a look at the domain of a function today. Now, I want to say a few things about the domain of a function so that we can get to understand how we find the domain of any function, whether it is a polynomial function, whether it is a rational function, or whether it is a radical function. Now, I want to say this, that when working with real numbers, there are two rules that we should never break. The first one is that we cannot divide by zero. A number divided by zero is undefined, and therefore we should not break this rule, in that we cannot divide by zero. Number two is that we cannot take the square root of a negative number. We cannot take the square root of a negative number. If you find the square root of a negative number, you will obtain a complex number. For example, when you be told to find the square root of negative 16, this one is like the square root of negative 1 times 4. And in the same case, it can be the square root of negative 1 then times the square root of 4. The square root of 4 is 2, and the square root of 1 is I. And therefore, this one is not defined in the real number system because it is a complex number that we obtain as the answer. Now, it is imperative to note that the domain of a function consists of all possible values of x for which the function is defined. In that, we need to note that the domain of a function consists of all possible values of x for which the function is defined. In other words, it is the set of all possible values of x when plugged into a function without breaking the rules that we have already mentioned. That is the two rules. That we cannot take the square root of a negative number, and also we cannot divide by zero. Now, we need to find the domain of polynomial functions. Now, these are some of the examples of polynomial functions that I've just written. Now, this is f of x equals to 5x minus 4. Then f of x equals to 6x raised to 8 plus 13x raised to 5 minus 4x minus 10. And also f of x equals to x squared plus 7x minus 11. Now, how do we find the domain of these polynomial functions? Now, allow me to say this, that polynomials do not have a variable in the denominator or enter the root sign. And therefore, polynomial functions are defined for all values of x. That is, polynomials do not have a variable in the denominator. If they don't have a variable in the denominator, then there is no way that we can divide by 0. Then it does not have a variable in the root sign, and that means we cannot find that is the root or the square root of a negative number, and therefore it obeys the two rules, in that it does not have a variable in the denominator, and therefore the first rule is obeyed, and then it does not have a variable under the root sign, and therefore the second rule is also obeyed. And therefore, if it obeys the two rules, therefore polynomial functions are defined for all values of x. And therefore, the domain of polynomial functions is just all real numbers. That is from negative infinity to positive infinity. It is the set of all values of x. That is the domain of polynomial functions. Now, secondly, I want us to have a look at the domain of rational functions. Now, this is an example of a rational function. Now, how do we find the domain of this function? Now, looking at this function, considering the two rules of finding the domain of a function. The first rule is that we cannot divide by 0. And if this one has a denominator, because it has both the numerator and the denominator, that means we set the denominator not equals to 0. We set the denominator not equals to 0. Then the second rule is that we cannot take the square root of a negative number. And since this one does not have a square root sign, therefore we cannot consider the second rule. Now let us consider this rule that we cannot divide by 0, and therefore we set the denominator not equals to 0. And therefore the denominator is x minus 7, then it should not be equals to 0. Then that means that x should not be equals to 7. And therefore, the domain of this function is that it is the set of real numbers. It is a set of real numbers except x equals to 7. It is the set of all possible values of x except when x is 7. And therefore, this is the domain of this function. And when we represent it using a number line, then we shall have, this is a number line that is from negative infinity to positive infinity, then we have 7. So, since 7 is excluded, that means we can circle 7. Then we shade all the values that are ahead of 7 and those ones that are less than 7. That means 7 is not included. Then in interval notation, we can write it as a negative infinity. That is in interval notation, we can write it as a negative infinity, comma 7, then close the bracket. That is negative infinity, comma 7, close the bracket, union 7, comma positive infinity. Then we close the bracket that way. This means, this shows that the parenthesis shows that 7 is excluded. 7 is excluded. Now, the second example is f of x equals to x squared minus 3x all over x squared minus 8x plus 15. Now, how do we find the domain of this function? How do we find the domain of this function? Now, the first rule is that we cannot divide by 0. And since it has the denominator, that means we set the denominator not equals to 0. That is, the denominator should not be equals to 0. Then the second rule is that we cannot take the square root of a negative number. And since it does not have a square root anywhere, because this is a rational function, it does not have any square root. That means the second rule is ignored. Now, therefore, the denominator is x squared minus 8x plus 15, then it should not be equals to 0. Then we can proceed to use, that is a factorization method in this, because this is a quadratic equation, and therefore the sum should be -8 and the product should be 15. That is, the sum is negative. The sum is -8 and the product is 15. With two numbers, when we add them, we get -8, and when we multiply them, we get 15. The two numbers can be -3 and -5. That is -3 and -5. Because when we add the two, we get -8, and when we multiply the two, we get 15. Therefore, we shall have, that is x minus 3, then we close the bracket, then x minus 5, then we close the bracket, should not be equals to 0. When you expand this, you will get this. And therefore, from here, we can say that x minus 3 should not be equals to 0, or x minus 5 should not be equals to 0. Now from there, that means x should not be equals to 3, or x should not be equals to 5 in that case. Then the domain of this function is therefore a set of all values of x, excluding x equals to excluding x equals to 3, and also x equals to 5. That so long as x is not equals to 3 and 5, all the other values of x are included except 3 and 5. And therefore, this is the domain of this function. Example of rational function is f of x equals to 2x plus 1 all over x squared minus 16. And in this case, we have the numerator and the denominator. And therefore, we set the denominator not equals to 0. And therefore, in this case, we shall have x squared minus 16 should not be equals to 0. Now, we always know that a minus b, close the bracket, a plus b is just the same as a squared minus b squared. That is a difference of two squares. It is just the same thing that we shall do here, in that we shall have x minus 4, then we close the bracket, x plus 4, then should not be equals to 0. Then in this case, we shall have x minus 4 should not be equals to 0, or x plus 4 should not be equals to 0. Then from there, that means x should not be equals to 4, or x should not be equals to -4. And since that is what we have, then the domain of this function is just all real numbers except x equals to -4. That is, except x is -4 or 4. Those are the two exceptionals that we have. This is the domain of this function. Now, radical functions are functions that contains square roots, or cube roots, or fourth roots, or fifth roots. And therefore, that means radical functions are functions of this form. That is, the expression is inside the root sign. It is inside the root sign. And I want just to whet your appetite a little bit, so that in our next video, we shall look at the domain of radical functions. That is, we shall look at examples. But in this case, I want us to only look at how we can find the domain of radical functions. Then in our next video, we shall look at examples. Now, I want us to consider this n. And allow me to say this, that if n is odd, that if if it is a cube root, that means our n is odd. If it is a square root, our n is even. So I want us to know this, that if n is odd, then the expression will be any real number. The expression will give us any real number. The expression will give us any real number. If that is, if n is odd, the expression will give us any real number. For example, I want us to consider the cube root of 8. The cube root of 8 is 2. Then the cube root of negative 8 is also negative 2. These are two real numbers. These are two real numbers. Now, it is imperative to note that the domain of radical functions with an odd index, because this is the index. So, I want to say that the domain of radical functions with an odd index is all real numbers. We have proved it here. That if the cube root of 8 is 2 and the cube root of negative 8 is negative 2, and they are all real numbers, then we say that the domain of radical functions with an odd index is all real numbers. And from that is the two rules that we know, that we cannot take the square root or the root of a negative number. And in this case, we have taken the cube root of this, and it gives us a real number. That means that the domain of radical functions with an odd index is all real numbers. Then the second rule is that we cannot divide by 0. And in this case, we are considering radical functions that they have, that is an odd index, because all radical functions, they have they have the root sign. For a function to be radical, it has the root sign, and therefore if the index is odd, then we can say the domain of that radical function is all real numbers. Secondly is that if the index, that is n, is even, for example, square root, fourth root, sixth root, and so forth. If n is even, that means the expression that is inside the root sign must be greater than 0. Must be greater than or equals to 0. That is what I mean. That if n is even, that is the index is even, then the expression that is inside the root sign must be greater than or equals to 0. Then let us consider this example. The fourth root of 16, the fourth root of positive 16 is 2. And the fourth root of negative 16 is 2i, of which this one is not real. This one is not real, but this one is real. This one is a complex number. It is not a real number. This one is a complex number. Therefore, we can conclude and say that the expression that is under the root sign, if the index is even, should be greater than or equals to 0. Ladies and gentlemen, this marks the end of our lesson today. And in the next video, we shall look at more examples of radical functions.